Guys, today we are going to solve our third problem, longest substring without repeating characters. It says, given a string S, find the length of the longest substring without duplicate characters. The most important thing here is longest substring without duplicate characters. First, exactly what is a substring? A substring is just a slice of a string. For example, given this string ABC, ABCBB, a substring can be each individual character. For example, A is a substring, B is another, C another one, A another one, and also combinations of continuous characters. For example, ABC is another substring, BCBB is another substring, and I don't know, and also ABCB, and also the whole thing can be seen as a substring. So we must find the longest substring without duplicate characters. For example, ABC is a substring that doesn't have any repeated characters because A is only one time, B also, and C is also one time. But for example, this CBB it's not a substring without duplicators because, as you can see, B is it's 2 times in the substring. To solve this problem, what you should do? First, obviously, you need to create a pointer to traverse the whole string, and you also need obviously a counter of our length. Let's say math length equals 0. And you need to create a hash map that contains the letters that we have already seen. Let's see, for example, let's create our hash map here that holds the letters that we have already seen. So, for example, let's suppose we are traversing our string. We are going to say something like this: hey, it's A in our hash map. Like it's not, let's add it. And now it's B in our hash map. Clearly it's not in our hash map, so let's add it, and so on. So if you in order to calculate the max length of our substring, we also need a left pointer. Why? Because suppose you have the substring ABC and you want to know how the length of it. You are just going to take our right pointer position and our left pointer position, and that will be our current length. So let's see, our current length equals right pointer minus left pointer. Let's suppose this scenario. Our right pointer index here is 2 and our left pointer here is 0. But as you can see, there are not only 2 characters, there are 3. So we must add 1 to our current we must add 1 to our current length. Give me a second here. Okay, perfect. So our current length, as you can see, will be only 2. So let's do the problem. It's a in our hash map. No, so let's add it, and let's do our current length calculation. Okay, it's 0 minus 0 plus 1. Our current length is 1, so our math length will be also 1. Let's move. In our hash map is b, like it isn't, just let's add it. And let's do our math once again. Our current length is 1 minus 0 plus 1, and now it's 2, and our math length will be 2. Let's move on our right pointer. Now let's add our hash map, the c, because it isn't, and now 2 minus 0 plus 1 equals 3, and our max length will be 3 by default. And now let's move. It's a in our hash map. Yes, it certainly is. So what we should do here, we move through a verb. We take our left pointer and erase and delete from our hash map the letter that is currently in our left pointer until we have reached the letter A. So in this case, we are just going to remove the J here, move the pointer, and yes, because we have here the J, we must put it once again. And now let's do the math again. It's the position is 3 minus 1 plus 1, it once again 3, so we not need to move our current length. Let's do it once again. So it's b in our hash map, yes, so let's delete it, and let's move our left pointer until we have deleted the letter b. And once again, let's put our b in our hash map. So we need to move each pointer, and it's exactly the same, so we don't need to change anything. So it's c in our hash map, just remove it, move our left pointer until we have deleted our letter. And now let's put C once again. So 3 right here, 5, so, and we don't need to change anything. So let's move our right pointer, it's b in our hash map, yes, let's move it until the b is not in our hash map. So actually, I'm sorry, first we must need to delete a, and once we have deleted a, we need to delete b, and we have only c and b. And now once again we are going to move our left b here and move our right pointer to the c and b, and that's all. So how can you do this in code? First we need to create our hash map. Let's say our hash map, I'm going to call it my list, I'm going to use asset because it's very easy to do it with assets. And now let's create a currently we are going to create it in our loop. We are going to create now our math length that is going to be 0. We are going to create all right and left pointer, right pointer equals 0, left pointer equals 0, and we are going to traverse the entire string. So for right pointer, as long as right pointer is lower than stop length, right pointer plus plus. So let's create our current length. Our current length will be right pointer minus left pointer minus 1. But remember that first we need to add all char in our hash map. So how can we do it? Pretty easy. My list dot add and our char. That our char is a position right pointer. And now, maybe you're wondering, hey, what should we do right now? We need to check it. Oh, first, remember that we must. By the way, remember that we need to check the max length. Max length equals math current length, and first math length and also current length. And remember that we must need to check if we have our right pointer already in our hash map. So we need to delete all the items that are in our hash map. So we are going to say while my list dot have is my list dot has is dot right pointer. We are going to do this to our list. We are going to delete our s to our left pointer, and let's move our left pointer to its right. So that should do the work. Oh, and remember to return our max length right here. So let's see, if while my list has s at position right pointer, we are going to delete the string at our left pointer. Let's move left or right. Let's move our letter to our hash map. Let's calculate our current position, and let's save and let's check what is the greater. Let's see if this works. Okay, new set. Left, oh right, left pointer. I'm sorry. And it's working, and let's submit it. It should be working too. Yet perfect. Actually, the runtime can be different if we put, for example, instead of my list set and another things like instead of a rave pointer, we're going to just call it rp, and instead of left pointer we call it lp, and things like that can help to optimize our code. The test case if f.length equals 0, we're going to return 0, and if f.length equals 1, we need to return 1. I forget to do that, so let's check. Now, okay, now it's 8078. Okay, perfect. A little better. And well, that's all for today. See you tomorrow.